The number of unread emails in Anthony's account is 110. The number goes by 25 emails a day. Okay, so could you find this function without me telling it to you? Because you'll have to do that a lot. So in this case, sometimes we give you the function, sometimes we don't give you the function. Okay, but does it make sense that that's the function? It's how many unread emails do you have? So we'll use n of t. Last example, use f of x, but you can use any letter you want for the function name and any letter you want for the input variable. All right, so if it's currently at 110 and then 25 a day, it just makes sense that for each day you're increasing by 25. So after the first day, 25 more. After the second day, it's 50 more. Third day, 75 more. And there's 110 to start. Okay, so if you remember when you studied lines, you call that the y-intercept, and that was the slope. It just so happens that the situation you're given turns out to be a linear function. Right? It could be, and that's a lot of times what we do in math is we decide what kind of function it is. Based on this situation, we ended up with a linear. But we're focusing just on the function concept. So again, this is your input, or independent, we called it, independent variable. And this whole thing here, n, using the notation t, it's really the functions is n or n of t. This is your output, or your dependent variable. Right? That is these values depend on these values. So you input t and you output n, right? If it's 3 days have passed, it's 75 plus 110. If 4 days have passed, 25 times 4 is 100 plus 110. And that's what we want to do, be able to interpret these mathematical models, right? Not just do the math, but understand what they mean. So what's n of 14 mean? Well, first let's do the math. N of 14 equals 25 times 14 plus 110. Okay, so maybe I go to my calculator to figure out what 25 times 14 is, and then I add 110 to it. So this should be 350 plus 110 equals 460. So let's interpret that. What does that mean? That means if 14 days have passed, input, then I have, or Anthony has 460 unread emails. All right, more on functions. Great. Let's talk about the graph. So we have all these ways to represent functions. In this example, we got 4 ways to represent a function. I'm sorry, 3 ways to represent a function. We have what we've seen before, the equation way, x, f of x, the table way, and now we have a new way, a graph. So let's do this one real quick. If I input these x values, what do I get as my output? Input -2, that's -6 plus 2 is -4. -1, -3 plus 2, -1. 0, the intercept, y-intercept, plug in 0 for x. 3 times 0 is 0, output 2. Everybody see what I'm doing here? If you wanted to write them out, what's f of 1? 3 times 1 plus 2, that would be 5. F of 2, 3 times 2 plus 2, that would equal 8. Okay, and then this third column isn't necessary, but if we want, we can kind of write them as ordered pairs. That's just these two guys together, -1 comma -1, just to help us graph. I don't know if we really need that extra column. I'm just going to go find these on my graph. -2, -4 is right here. -1, -1 is right here. 0, 2, that's called an intercept. That's the y-intercept where it crosses the y-axis. 1, 5 is here. 2, 8 is here. And you might have remember a different way to graph these. This is a line, right? So this would be like the long way to graph it, just plot a bunch of points. But you might remember this has a slope 3 and a y-intercept of 2. So you can do the thing where you start at 2, go over 1, up 3. Over 1, up 3. Why does that one look funny? 2, 2, 8, over 1, up 1, 2, 3. That's right. And then you do your best to graph it. I could use my line tool, but let's just do our best to graph that line. Okay, so important things to remember here. We just graphed 5 points, but there's really an infinite amount of points on this guy. The domain in this case, we can always talk about domain and range of these guys, so let's do it. These lines indicate it's going forever, so that means it goes left and right forever, right? As this goes down, it's going to go to the left. Those are our x values going back. It's going to go back to negative infinity, and then it keeps going to the right. I know it looks like it's up and down, which it is, but it also goes left, right forever, right? So the domain, these are my x values. They go from negative infinity to infinity. The y values, these ones are a little easier to see because of the steepness of my graph. It goes up forever and down forever. So starting at the negative values, we go down to infinity and up to infinity. All right, let's see. We want applications. Let's see if we got an application here. Okay, same idea. I want to work these applications into these lessons as much as possible so we know what this is, the context of this math. So here's a similar example, but there's a real basic physics problem that can represent a quadratic function, can model the height of an object in a vacuum at time t. So here's a real basic example. Input t. Now what I don't have on here is t is measured in seconds, which I should have on here, and s is measured in feet. Okay, that's important for an application. We need our units. So what happens when I plug in -2? Well, actually, that one doesn't make sense. I added the application to this, but I forgot to kill my negatives. Why doesn't that make sense? Well, let's talk about the domain right away. Right, the domain on this thing, if t is time, has to be from 0 to what I think is infinity. I'm going to start with that, and then we're going to look at that again in a second. And then the range I'll save for later. Just the range a lot of time is, well, what's the range of this function? Well, the range is going to depend on my independent variables, right? My t values here. Okay, so I know it looks like the domain is 0, 1, 2. Maybe we can make this chart longer. But what are the outputs going to be? Well, let's take a look. When time is 0, the height's 5. So it's like starting here. When time is 1, the height is, now you got to be careful with this one. Let's do this one. S of 1. Your choices are 6 or 4. -1 squared. Is that +1 or -1? Well, we got to be real careful. It's -t squared, right? So that means I first square the 1 and then I make it negative. So that's actually -1. And that should be 4. So that's 4. How about 2? Well, S of 2 is going to go down real quick. It's going towards the ground. S of 2, same idea. You got to be careful with this. That's -4, right? That's different. Just real quick, that's different than this. Right? That's +4. That's not what we're given here. We're squaring the 2 and then making it negative. So that would be -4 plus 5, and that's +1. Okay, so let's see if we can figure out what's going on overall with this thing. We know we can't have negative time, so there's no negative inputs. We got a 0, 5, we got a 1, 4. Oops, we got a 1, 4. We got a 2, 1. So I got this parabola looking thing, and I'm not quite sure when it hits the x-axis, but let's find that out. This is that reverse problem. Okay, so that means if I want to figure out the input for a certain output, I can do that. So I want to know, when does it hit the ground, or when is the height 0? Remember, S represents height. So when is that 0? That might be a useful point for us. Well, let's figure that out. All right, so this is backwards. I'm not plugging in t, I'm plugging in the output and finding the input. So if you remember your algebra skills, I'm going to add t squared to both sides, which gives me t squared equal to 5. And then I got to take square roots, which gives me t equals usually we're looking at plus or minus. It gives me 2 roots if you remember your quadratic stuff. But in this case, the negative root we're not worried about because we know the domain is just positive value since it represents time. So I can get rid of that one. And I just have to worry about the positive root. Okay, so that would be, go back to my chart. If I had a column to this, relationship between inputs and outputs, what I did was I was interested in when is that 0? And we got the square root of 5, but that's kind of hard to graph. So I'm going to go to my calculator and figure out and plug that in and look at it as a decimal value. So I'm going to go 5 square root, and we get about 2.24. And then I'm going to plot that. That's about right there. Okay. Oh, so this is good. So now we can adjust our domain, right? Because we can't have negative height. So that's it. This model ends when the ball hits the ground, right? So this is a good problem, how the application changes my domain. It starts when time equals 0 and ends when it hits the ground. That's at 2.24 seconds. And now we can get the range. I can see the range here. The lowest value is 0, the highest value is 5, and those are included. So in my interval notation, that would be the range.